Welcome to Python Lists. In this lecture, we'll learn about lists and how to access, slice, reassign, and delete them. We'll learn about multidimensional lists and we'll see how to concatenate them, operate on them, and iterate on them. We'll learn to build list comprehensions and talk about some built-in functions and methods. Let's go. Python does not have arrays like in C++ or Java, but it has lists. A list is a collection of values that may be different. This is a list, red, green, blue. Let's call this colors. Another list, days, has values in different representations for the 7 days of the week. Yet another list contains 3 other sublists and the values Romanian and Spanish. The first item in this list is indeed a list too. This one holds a tuple along with other values. Languages of 0 is this tuple. Can we assign Albanian to the first item in this? No, because although lists are mutable, tuples are not. Let's learn how to access lists. Print days, and we have the entire list printed. To access a single element, we can use indexing. Let's use the first version of the list, languages, for this. The first element is English. Since indexing begins at 0, the first element is at index 0, and this is English. The second is Gujarati at index 1, and so on. But languages of 1.0 raises a type error because you cannot index using float values, even if it's only a 0 after the decimal. To access only a part of a list, you can slice it. This is list indices. This slice gives us the values at indices 2 to 3, which is 4 minus 1. This gives us the list 2 and 3. Let's see how this happens. This list has indices 0 to 5 since it has 6 values. This slice goes from index 2 to 3. Let's try some more slices. Up to index 3, which is 4 minus 1, we get this list. These are the indices of the list. This slice goes from index 0 to 3. A slice from index 4 and above gives us this list. This slice goes from index 4 to 5. Without any indices, it gives us the entire list. What happens if we use negative indices? From right to left, we have indices minus 1 to minus 6 here. This means index 0 is the same as index minus 6. Index 2 is the same as index minus 4. They give us the same item. A slice from the beginning until index minus 2. This goes until before the second last item. This gives us this list. Index 1 to minus 2, which is the second value up to the second last, we get this list. And slice minus 2 to minus 1, which is second last up to last, left to right we get a list with just the item 4. And now with negative indices, slice minus 1 to minus 2 means the last element up to the second last element, but for that we'd have to traverse right to left, because left to right we get an empty list. This is because here the start is ahead of the stop, so it has nowhere to traverse. Lists are mutable. What this means is that once you have defined a list, you can always change or reassign items or even the entire list at once. This is the list colors. Colors is this list now. Let's reassign just a slice. From index 2 up to the end, the new slice is the values bronze and silver. So this replaces the values silver and ochre with the values bronze and silver. Again, colors is this list. We reassign the slice 2 to 2, which is simply index 2, with bronze and silver. Colors is now this list. And if we now reset colors and set index 2 to ochre, colors is now this. It adds the value ochre at index 2. We can also reassign single elements. Colors is this list and we set index 3 to bronze. So this sets the fourth value to bronze. This gives us a name error because there's no list color. It is colors. We can also just reassign the entire list with a new one. And if you no longer need a list to exist, you can delete it or any part of it using the del keyword. Let's delete an entire list. Printing it now gives us a name error. We can also just delete a few elements. If we delete the slice 2 to 3, it works. And we can delete a single item. Deleting the first element deletes caramel. You can also put lists within lists. This is a list grocery list. It holds other lists for items that belong to the same aisle: caramel, peanut butter and jelly, onions and potatoes, and flour and oil. And this one is another list nested deeper than 2 levels deep. To access the value 4, we need to get into the first item, in this the second item, and in this the second item. We can also merge 2 lists together to create a splice. This preserves their order. 2 lists A and B. Let's concatenate them. 3, 1, 2, 5, 4, 6. How does this happen? The 2 lists come together and the value 5 gets next to value 2. Now, there are various operations we can perform on lists. We can multiply a list by an integer. This creates that many copies of it. This is the list. Multiply it by 3 and you have it 3 times. 3, 1, 2, 3, 1, 2 and 3, 1, 2. But we can't multiply lists by floats. That raises a type error. Let's see other operations on lists. Membership. Is 1 in A? Yes, it is. Is 2 not in A? No, it is. Sometimes we may want to iterate on a list to operate on or access its values. For values 1, 2 and 3, this testifies the composite nature of each value. So for 2, this prints 2 is composite. There is a shorter way to create a list. This is a list comprehension. For each value in the range of 1 to 10, put twice the value in the list. So it adds 10 even numbers to a list. You can also put in if statements in this. Do it only if it is also divisible by 3. This leaves us with the values 6, 12 and 18. Finally, let's discuss some built-in functions and methods on lists. Len calculates how long a list is. Even is 3 items long as it has the values 6, 12 and 18. Max returns the item with the greatest value. 18 was the greatest. Out of this list, the string 3 is the greatest. And this one is thrown off balance because it cannot compare integers to strings. That is like comparing apples to oranges. Min returns the smallest item. Min of even is 6. And sum? It returns the sum of all the elements in a list. 6 plus 12 plus 18 is 36. It cannot perform this addition because these are strings holding integers. But it can add floats. Sorted returns a sorted version of the list without modifying it. It does this in an ascending order. 312 sorts to 123, but the original list remains the same. With strings, it sorts them based on their ASCII values, so this list of strings sorts to this. The ASCII for the capital H is 72, and that for the small h is 104. So, capital first. To convert any compatible data type into a list, use the list function. The string ABC becomes the list A, B, and C. We say compatible data type for a reason. If you try converting a single int into a list, it gives us a type error. Any returns true if even one item in the list is true in Boolean. The empty strings are false, but one is true, so true. All returns true only if all items in the list are true. But two are false here, so false. Apart from functions, we also have some methods we can call on lists. Append adds an item to the end of a list. If we have the list 213 and append 4 to it, it adds 4 to the end. Insert will add the item wherever we tell it to. Insert 5 at index 3, and it will. Remove removes the first occurrence of an item from the list. This list has two instances of the number 2, so it removes the first but keeps the second. To pop, we specify the position of the item to remove. It removes it and prints what was removed. Pop the item at index 3. It pops 2. Now print A, and we can see that 2 is gone and the indices have been recalculated. Clear empties a list. This empties the list A and prints the empty list. Index looks for the item in the list and returns the index of its first occurrence. 3 is first found at index 1 here, and count returns the number of times an item appears in the list. 3 appears twice in this list. Finally, sort and reverse. Sort sorts the list in an ascending order. So 1, 3, 5, 3, 4 becomes 1, 3, 3, 4, 5. And reverse reverses elements in a list. If we reverse the now sorted list, it is equivalent to sorting it in a descending order. Now you know about lists and how to play with them. Don't forget to check out the proofs of concept and the assignments so you can keep track of how you're learning.